All right, so today's Friday, and we'll wrap up our talk on subsetting. I'm going to have to skip over some stuff. You're going to have to go through these slides on your own time. So you should be able to download the RMD file for the lecture, render it on your own computer, and kind of just flip through the HTML slides yourself. But I'll talk about things that are kind of important, and then the other things I'll let you guys take a look at. So there is stuff happens when you try to subset and you ask for things that do not exist, okay? And this is what we mean by out-of-bounds indices. So for example, you might have a matrix that is 3 by 3, 3 columns, 3 rows, okay? And then when you subset that matrix, you might say, give me the 4th column, give me the 4th row, okay? That's what we consider something that is out of bounds, right? Because the matrix only has 3 rows and 3 columns, so the 4th row or the 4th column, that does not exist, okay? Or you might have a vector with only 4 numbers in it, and you ask R, what is the 5th element, okay? And depending on what we have, what R returns could just be an NA, could be that value doesn't exist, or it could give you an error or things like that, okay? So for atomic objects, such as vectors and matrices, if you go out of bounds, it will return NA, okay? If you ask to subset based on the null operator, it will return back, character 0, integer 0, or something of that nature, okay? And if you do any kind of things like this, give it an out of bounds operator, it will return back null, or things like that for a list, okay? Now you might ask, why would I ever subset X with NA? Okay, here it says NA real, but you're asking R to subset something based on an NA. Now you probably won't do this intentionally, okay? However, unintentionally, you may end up subsetting with a missing value, okay? Can you guys think of when that might happen? So let's do an example here. So let's say you have some kind of vector, 1 through 4, whoops, right? And then you might say, when is x less than 3, okay? And you get true, true, false, false, something like that, okay? Now you might try to use this to subset. You might have letters. You might subset a vector using x less than 3, and it would return the values a, b, not c, d, and then it recycles e, f, not so on and so forth, and it would return back something like this. Now if for some reason, let's say instead of doing x less than 3, you had y, which was the vector 3, 4, NA, and 2, okay? So for some reason, you have a missing value here, and you don't realize that. Then if you try to subset using something like that, okay, now you are subsetting with an NA value. And you get all of these NAs in here, okay? So you probably aren't intentionally subsetting using NAs, but you might use a logical condition, and for whatever reason in your logical condition, you might have an NA value somewhere in there, okay? And then that will get carried forward, okay? And then if you try to throw the NA into an if statement, okay, you think you've got a logical value, you try to throw that into an if statement, you're going to get an error, right? You You can't do ifs with NAs. Okay, so anyway, and then it'll kick back errors here. So keep that in mind when you're subsetting using some kind of conditional or some kind of evaluation where you might have missing or things that go out of bounds. Okay. Subsetting can be combined with assignment operators, and so if you have the values 1 through 5, you can say I want a subset based on the first. I just want the first 2 values, and we're going to replace those with 2 and 3, and it works just fine. Okay. And then if the important thing is that the length of the left-hand side needs to match the length of the right-hand side for it to go through. If you do duplicate indices, here you get, this is a vector of 2 with just the first thing twice, and then when you replace it with 2 and 3, basically the 2 goes in and then the 3 goes in, and then so when you ask what is x, it only has replaced the first item with 3. And likewise, if you try to mix in NAs and things like that, then you get issues. Okay. Probably subsetting with assignment is most useful when you're trying to conditionally modify a data frame. So here we've got a data frame with the column 1 through 10. I'm sorry, 1, 10, and NA. Okay, and then here we can just say modify A where A is less than 5. Okay, replace that with 0. Okay, and so that goes in and it replaces the 1 with the 0. So you can put in a condition. You're subsetting the column A, with this condition saying wherever A is less than 5, just replace it with 0 or replace it with some other value or something like that. You can do that, right? And then if you had a different column, if you have 2 different columns, you can say in column B, enter this value wherever column A has this condition. Okay, and that's a very useful thing to have. Okay, and you can subset with nothing, and that's useful because it preserves the original object class and structure. Okay, so here empty cars remains as a data frame because we've got empty cars with a blank subset instruction, and we're saying list apply. So lapply means the output of lapply is always a list, right? So you guys learned apply functions in Stats 20? A little bit, right? So you got lapply, which always returns a list, and sapply, which kind of simplifies it to whatever it can, but not always very successfully. But anyway, so if we do this, empty cars will remain as a data frame, whereas if we do this, just the output of lapply goes into the name empty cars. Okay, so here it just says take the output of this and put it into a new object or an object called empty cars. Here, this says we are subsetting empty cars, therefore try to preserve the structure of empty cars, and then the output of the list goes in and it remains as a data frame. Whereas this, it's just basically saying, here's just a new name. Oh, there's something already called empty cars, who cares? Just, this is now the new empty cars object. You can use assignment with the null operator to just kind of kill things, okay? So here we've got the list A and the list B. I'm sorry, the list with the objects A and B inside the list. And here I'm going to just put in null for what is B. Okay, so this is the same as doing $$B or whatever. And basically that just kills the, completely eliminates $$B. So if we ask what is X, what's the structure of X after this assignment operator, it's completely gone. So if you want to like remove a column from a data frame, you can just overwrite that column with a null, and that just completely removes the column from the data frame. Okay. This is, if you throw the null into a list, then that item remains, and it's the list object. It's a list object containing the object null. Okay, so you don't want to do that. I mean, unless that's what you want to do. But generally, if you're trying to just remove something, you just say you put the null object in here, and then it eliminates it, right? Okay. Here are a few important applications of subsetting. I'm going to maybe just talk about a couple of them and then skip over the rest, and I'll leave it to you guys to go through the notes on your own time to take a look at some of these things. Okay, you can, because R allows for repeat indices, when you're doing subsetting, you can create lookup tables, right? So here we have X being some vector, M and F and U and things like that, so people's sexes. And here we can create a lookup table where we want to maybe expand. We want to say basically wherever you see M, say male, and wherever you see F, say female, and then if U is unknown or not defined, you know, put in a missing value here. Okay. And so when you subset this vector, which only contains 3 values, with using X, which contains however many, 7 characters, so we're doing character subsetting, but we are subsetting a shorter vector with a vector of 7 values. And because you can have repeat indices, we get back a vector with 7 values. Okay, so effectively we have created a lookup table where we are just subsetting this short table, or the short vector, subsetting it using the long vector, and because of the repeat indices that R allows, we get back the full vector. Okay, and then if we just want the values, we can throw the result of that into unname, and it throws away the names, and that's what we have. Okay. And this is just a shortcut. Instead of actually creating lookup and subsetting lookup with X, here we're going to just create a vector, and we just subset the vector directly inside unname. Okay, and it's okay. Here I've got one lookup M will be known and F to be known, and it's fine. It doesn't care that this value is repeated. Just a quick question here. This vector lookup, what kind of vector is it? If I did type of lookup, what would I get? It's a character vector, right? It's got character values, male, female, those are character values, and then the missing value. Okay, and if I asked for the attributes of the vector lookup, what would it say? The attributes of lookup, the only thing that exists here are names, and there are 3 names, M, F, and U. Right? Or maybe that's like in a hurt. That's the. Oh, I should mention that I've posted a homework assignment. But here, we'll just. So if I do lookup and I say what are type of lookup that says character attributes of lookup. It just has the names. Okay. Okay, it's a named character vector with that. Okay. Just we'll pause here, and I will say a homework assignment has been posted under week 2. The RMD template for homework 2 has been posted. I'm afraid of posting it now because I don't want you guys to get ahead of yourselves. So a lot of the things in homework 2 ask you to write functions, and we haven't talked about writing functions yet. We'll talk about that next week. I've also changed the deadline due date for homework 2 just because I've realized we haven't covered certain things. That's going to be due January 31. Okay, so that's basically in 12 days. So it's due January 31. You've got lots of time. Don't, go ahead and take a look at the homework, but don't stress out about it, okay? And then part of the homework assignment, so if you're gonna work on it at all this weekend, and I would just say, just take it easy this weekend as far as this class goes. You can take a look at it, and I would say if you're gonna write anything, just write on the first few problems where I have you look at the textbook, okay? So, if you're like, what textbook? Go on, in the syllabus, I have links to textbooks that are freely available. Take a look at those textbook problems and then see if you can work through some of those. Don't worry about the tic-tac-toe just yet, okay? We'll talk about tic-tac-toe next week, and then and you can start asking questions then, okay? Just because I do kind of list out in the homework, I give it excellent directions on how I think you should approach the tic-tac-toe problem. And sometimes students who are over-eager and start writing their own tic-tac-toe thing now face problems with the homework because the homework's asking for the assignment in a certain way. Okay, and I've written the assignment in such a way that we can evaluate your program in an easy manner. So anyway, all to say, read the instructions before starting anything, and don't start tic-tac-toe just yet. Okay, don't get ahead of yourselves yet. Okay, I'm going to skip this part. This is matching by hand. This is kind of like lookup tables, except you're going to be looking up with a data frame. You can play around with this on your own time. It's a nice application, although we don't have to worry about it. Okay. Random sampling, same thing. You can basically create a vector of random integers and use that to select rows out of a table. Okay, and so if you want to generate a random sample from a table, you can do it this way. Again, in your own time, take a look at some of the code examples here. With order, this is, I guess, fairly useful. Okay, you might have some vector x. Okay, and here we've got the characters b, c, and a. And order will take as an input the vector and then returns an integer vector describing how to subset that vector so that the output will be ordered. Okay? So it's kind of like, because if I just wanted it sorted, I would just say sort x and it would return back a, b, and c. Okay? However, order is kind of like an in-between step between the input and the sorted vector. And it just says, if you are going to sort x, this is the order in which you would select them. You would select the third object, then the first object, and then the second object. Okay. And so you would, you can do this. Order of x gives you that thing, okay? There's some rules about how ties are broken, but you can think of the function order as kind of like an in-between step between x and the sorted vector of x. Okay. If you just want the sorted vector, you can go just straight to sort x, but order will give you the integers in order of how it should be ordered. Okay. If you got two or more dimensions, order, and you can order either the rows or columns of an object. Okay, so here we've just randomly sorted the thing, and if we say order based on column X. Okay, we'll say, sort df2, the rows, we want to sort them by the order of column X. We can see the result is X goes 1, 1, 2, 2, 3, 3. Okay, and again, it's just looking at X, so it doesn't actually care about Y or Z, and so you can see that Y goes 6, 5, 4, 3, and 1, 2, not 5, 6, 3, 4, 1, 2, or it doesn't look at column Z, so it goes A, B, C, D, F, E. It doesn't try to sort or order based on columns Y or X because those aren't factored in here. You can sort the columns by their names as well using order. We'll skip over this, expanding aggregated counts. This is basically if you have certain things, you can expand them out, but we won't worry about that. Removing columns, this is assignment using with null, so you can just delete columns. I think we already talked about that. And this is probably our most useful ones, is selecting rows based on a condition, okay? And so we can, we've already seen this earlier, where we subset empty cars, we select the rows where some condition is true, so we've done this. If you want to combine them, you can throw in the AND operator, and you've got two logical vectors, and the AND operator will return true only when both values are true, or you have the OR operator and things like that. R also has the double AND and the double OR operators, which only should be used only in if statements, okay? Because the single AND and the single OR are vectorized, meaning you would give it a vector, two logical vectors, and it goes element-wise between these two logical vectors. Whereas the double AND and the double OR only look at the first values in the logical vectors. It's expecting only vectors of length 1, but if you give it a vector longer than length 1, it will just look at the first elements, do the AND or OR operator there, and return only one true or false value there. You can, all of these logical rules also apply. You can just throw in nut operators and stuff like that. Okay. There is the function subset, which saves you a little bit of typing. So instead of having to say empty cars, where empty cars gear is equal to 5 or something like that, you can just say subset empty cars gear is equal to 5. Okay, so it saves you a tiny bit of typing, and you have this. Okay. We have Boolean algebra versus sets. Okay, so set operations use integer values, whereas the Boolean algebra uses the true-false values. Okay, and kind of the function that relates one to the other is going to be which. Okay, so which will turn a logical vector into integers. So here I've got the values 1 through 10, and I just say which I want, the integers that are less than 4. Okay, and so after we've shuffled them, this value, and this value are returned true, and the other ones are false. And then so here I've got a vector of true-false values. If I use which, then I get a vector of integers that correspond to true. So it says elements 2, 3, and 10 correspond to true. In R allows you to subset using logical vectors or with integers. So if I threw either of these things into a data frame, let's say we had a data frame of 10 rows, and I say you know, data frame, and I do bracket, and I do X, comma, it will return back the second row, third row, and 10th row, because it will return back the rows that correspond to true, which is the second row, third row, and 10th row. R also allows you to subset using integers, and so if I said df bracket which x, comma, it will return back the rows 2, 3, and 10. So the result will be the same if I subset using the logical vector or the which x integer vector. Okay, so that's a nice thing about R, is that either of these things can be fed into a square bracket to subset, you know, the rows or your columns or whatever it is that you're going for. But it is handy to be able to go back and forth here. Okay. Here we'll take two logical vectors and their integer equivalents, and then kind of see how these which vectors work. Okay. So x1 will be basically the even vectors. Okay. And x2 it will be a logical vector where we have true for the even values. So I got 1 through 10. And where the mod 2 is equal to 0, so basically the even values. So x1 is the logical, x2 corresponds to the integers, 2, 4, 6, 8, 10. And then y1 will be those divisible by 5. Okay, so I've got true at the 5th element and the 10th element. Everything else is false for y1. y2 is the integer vector that corresponds to 5 and 10. So if I do the AND operator, then it's going to do basically AND of all of this true-false vector and this true-false vector, and it returns back basically false for everything and true only for the last element. Okay. Whereas if you were dealing with integer vectors, the operator that you would use is intersect. Okay, the intersection of 2, 4, 6, 8, 10, and 5, 10, that intersection is 10. Okay. The OR operator on true-false vectors corresponds to the union operator. Okay, so here we would get trues and falses pretty much over here, and then we get the same thing. The inner union of x and y, when we're talking about their integers, are 2, 4, 6, 8, 10, and as well as 5. Okay. So if we fed this into which, we would get this. Okay. Can you guys still hear me? I think my mic just cut out. And if we feed this into which, we would get back the operator here for union. Okay. All right, is this okay? And then, you know, same here. Set difference is what is in x but not in y. Okay, so this is x and not y. We would get this, and then set difference. Same thing with for the set operators. Is what is in x, so 2, 4, 6, 8, 10, that's not in y. Y has 5, 10, so that's just going to be 2, 4, 6, 8. Okay. The exclusive OR means one has to be, you want one true and one false. If they're both true, then the answer is they're false. Okay. So exclusive OR returns true as long as they are different from each other. Okay, so here, one we have 2, 4, 6, 8, 10, and the other one we have 5 and 10. So exclusive OR will return true for 2, 4, 6, 8, and 5. Okay, because the 10 is common to both, so it doesn't qualify for exclusive OR. So anyway, the relationship between logical vectors and set operators is possible, and again, either of these if you're more comfortable dealing with the logical vectors, you can always use the logical vector and then throw it into a which operator, and it will return back pretty much what you would get here, okay? Or you can go directly for the set operators if you're comfortable dealing with kind of set functions as well. Okay. So again, you could do x subsetting which y or x subsetting y, and here, you know, using which doesn't do anything because it switches from logical to integer subsetting, and it will be exactly the same. So you could do this, but it really doesn't do anything. Okay. If you do x subset minus which, okay, this is not the equivalent to the same thing as the not operator on y. Okay. If y is all false, then which on y will be integer 0, okay? And if you do the negative operator on that, you'll still get integer 0, so you'll get no values instead of all the values, okay? But other than that, there's not a whole lot of. You could use either the integer subset or the logical vector there. Okay, so now we'll start talking about programming, and in terms of things like flow control, which is controlling how R handles your arguments. And so we'll start off with some of the basic things here. And whenever you work on something like a homework assignment, the key thing is where is the file or the script that you are writing, okay? And that will, by default, kind of define where your working directory is, okay? And so I would strongly recommend against, so this is a bad idea, is to just download the RMD template from CCLE, and then it goes into your downloads folder, and then if you open it up there, then your downloads folder is probably going to become your working directory. And unless you have a brand new computer, your downloads folder is probably full of a bunch of junk. And then when you refer to certain objects, you know, it will default to kind of searching your downloads directory. It can just get messy, okay? So you should, somewhere in your computer, create a folder for this class, and within that class, and within that folder, create another folder for each homework assignment. So create a folder for homework 1, create a folder for homework 2. Then download the file, move that file into your homework 2 folder, and then work there. And then your homework 2 folder will be your working directory. And then if you need to open up any kind of files or anything like that, you can set it there. You can set your working directory by typing in the path directly. RStudio, I often just do session set working directory to source file location, and that will set the working directory to wherever you have opened it up. Okay, so under session, you can always do set working directory. Or you can manually choose the directory yourself using the graphic interface. If you are creating a script that you're going to share, it's not a bad idea to put in set working directory to some kind of path that will be universal. You can add comments in your code using the pound sign or the hash mark or whatever you want to call that. RStudio has a nice little feature in that you can select lines of text, and then if you hit Command-Shift-C or Control-Shift-C, it will comment or uncomment the entire block there. Okay, so as you're going through, you can just hit Control-Shift-C, and you can turn on or off certain lines of code. Okay, of course you can go through and type in the pound sign yourself. Okay, I always think it's a good idea to clear the environment, because and this is a lot of times people will send me an email 5 minutes before the homework assignment is due, and they'll say, like, I got all of my code working, but for whatever reason, it's not rendering, like, I can't knit the file, okay? Well, 5 minutes before the assignment is due is not the time to send me this email, but whenever you start, I always get in the habit of just hitting this delete thing to just clear everything out of your workspace. If you don't have RStudio or whatever, if you don't want to click this button to do that, you can always do rm, and then you say list is equal to ls, okay? So ls returns back a character vector of all the objects in your directory. So if you just have 1 through 4 and y is 2 and d is something like this, and you do ls, it returns back a character vector of everything here, and then you would say remove y or something like that, and then this tells you what's left. If you want to just remove everything, you can do remove list equals ls, okay, and that removes everything. Or you could just hit the sweep button and do that. Just so you're in the habit of always starting off with an empty directory, a lot of time, I recommend this in under Tools, Global Options, where it says Save Workspace on .rdata, Save Workspace to .rdata on exit. I always say never, okay? So that when I start up R, it's always blank and it's always empty. I think that's a good idea because a lot of times, not a lot of times, but sometimes you'll want to share files or you'll want to continue working on something. And if you're in the habit of leaving things in your workspace and expecting certain files to exist, you know, that might not be true for everybody. And so you either want to, I would say in the script that you're working, you want to explicitly reference whatever object you will load into your workspace or create in your workspace. And you kind of want to work on the assumption that your workspace is empty to begin with, because it's, unless you're going to always be working on the same machine, it's not a good idea to expect that certain objects already exist in your workspace. So that's what I recommend. As you write scripts in RStudio, you'll just create a new R script, okay, and do this. You know, depending on whatever it is that you're doing, okay, you know, some of the things you can write your answers directly in the Markdown file, and then you would just click the little play button to run that current chunk of code, okay. If your code that you're writing, my kind of rule of thumb is if it's going to go over 15 lines of code, don't do it in the R Markdown file, but create a separate R script, okay? And that's because when you're working in a Markdown or a notebook or something like that, it just costs your computer a little bit more overhead, and you know, knitting the file will require it to run everything, and there's a lot of processing time devoted to just getting the text and pictures to go into an HTML file or something like that. I would say just work in the script separately, and then once you get this working, copy and paste that script into your RMD file. And then and make sure it works and renders appropriately, okay? And then I think you guys know that you know, as you write things in your script, you can just execute those lines of code just by hitting Control-Enter, or you know, if you have it saved, you can hit Source, and it will run everything that's been written inside your script there. Okay, we'll talk about conditionals, and so we have logical operators that you know, x and y being logical vectors. You have the or, you have the and you have the not. And these are vectorized in that you can give it vectors of logical vectors, and it returns element by element comparisons. Whereas the double or, the double and, these are not vectorized, and they only look at the first logical value in each vector. Okay, and that's just what this slide explains. Okay, so here, if I've got x being true, true, false, false, and y being false, true, false, true, when you do the OR operator, it returns back 4 values because each x and y vector has 4, whereas the double OR vector only looks at the first element and returns back true. Okay, and then with the single AND, it returns back 4 vectors. With the double AND, it only looks at the first values of each vector and returns back the result there. The exclusive OR, I think we've already talked about that, is it returns true only when one of them is true and one is false. Okay, and then the value is true asks, is it a vector that is of length 1 and without any names, and is the value true? Okay, so if you give it anything longer than one value, it's not going to return true too. Is it the value true all by itself? If you've got integer vectors or any kind of numeric vector, integer or type double, these are comparisons, and they're all vectorized. Okay, so this is greater than, less than, are they equal to each other, or are they different? And you have this. You also have is x in the vector y? Okay, so y could be kind of like a pool of values, and you could say is x inside y, and it is vectorized for x. So if you have 3 values you want to check, and you got a pool of 10 things, then it will return back true or false for each value of x if x exists inside the pool of y. And this is very handy. So if you have I don't know, state names or something like that, you could say is and you've got a vector of things. Is this a name that exists inside the pool of 50 state names? Percent in percent is a handy function there, or operator. So all of these conditionals, all conditionals depend kind of on this statement if. Okay, if expects a length 1 logical vector that's not NA. So it's expecting either true or false. Okay, and usually you'll put in some kind of condition inside there, and that will go into the if statement. Okay, if you give it an NA, it's going to complain. All right, if you give it a logical vector that's longer than length 1, it's going to kick back a warning. Okay, what's the difference between an error and a warning?
Warning will do its best to still execute the code, but it might be something wrong to let you know.
Yeah, so a warning allows the code to continue running, but it'll give you a warning and say, I'm not sure if this is what you wanted. An error will stop the code. It'll say, I can't go on. Okay, so you can say something like, if true, print hi, and then of course that will print, right? And if you say if false, then it's not going to do it. And if you say if NA, okay, then it kicks back an error. It says you gave me, it says a missing value where true false is needed. It doesn't know whether it should do the code or not do the code, because this thing doesn't, this value doesn't exist. Okay, and then if you give it a vector that's longer, okay, it does its best. It looks at the first element, but then it kicks back a warning, and it says the condition has a length greater than 1, so only the first element is used. Okay, so it kicks back a warning there. Okay, So here we have x is the values 1 and 3. Is 1 in x? Yes, that's true. So if 1 is in x, print hello. We say is x greater than or equal to 2. That says false and true. So here we say if x is greater than or equal to 2, it doesn't run the code because it looks at the first element false, but it kicks back a warning and says we're only going to look at the first element. Okay. And so instead of doing, if you have something like this, there is an operator called any. Any is kind of like or for everything. And so if you have a vector of 10 logical values, trues and falses, any will return back true as long as one of those things is true. Okay. The other function, like if you have several values and you want all of them to be true, then you would use all. So any and all are these kind of logical vectors for multiple things. So I can just say x is, I'm going to just say t, f, and f. So x is true, true, false, false. And if I say any on x, that will return true because it's just looking for anything there. All for x will return false because not all of them are true. So x has to be, here x is all true, and then so now all for x, or all of the values true, that is true, okay? What will happen if I do, if I throw in an NA here, okay? So if I do any on x, what do you think it will return? This will return true, because as long as one of those values are true, it's going to return true, okay? If I return, if I do all on x, this says NA, because it has to, it's only going to return true if all of the values are true. And so far, all of the values are true, but one is missing, so it says I don't know if all the values in x are true, okay? Let me do one more thing, okay? I'm going to throw in a false here, okay? So x is now true, 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 NA, and false, okay? Any on x is still true. All on x is now false, because now it knows that there's one false in there, okay? And then here, let's just do one more. I know, so I'm going to do false 5 times here, and y is, we'll throw in an NA here, okay? So y is now a bunch of falses and NA. So if I say all on y, we know that answer is false, but if I say any on y, this is NA, because it doesn't know if that last value is true or not, so it's going to say I don't know. Okay. So any and NA, any and all allow for to kind of the checking on all of these things. Okay, so anyway, this is just the beginnings of conditionals and program flow control, and we'll look at more stuff on Monday. All right, have a great weekend, you guys.